Hello grade 10s. So I'm going to go through a Ti Nspire example related to question 1 of exercise 13M, where some of you have asked me about how do you even put it onto the calculator. So I thought I would just go through this example and hopefully it will help you with the other ones, and then when you go on to do the Ferris wheel. So this is just the main focus on how to actually use the GDC, the Ti Nspire software, to put your graph in. So here's the question, which you can, if you're using a computer, copy this text and actually paste it in like a computer, or you can just manually type it out. So here I copied and pasted it in, or manually type it out, but you've just got to make sure that you have multiply in between the 5.6 and the sign. You make sure you got your brackets in the right places. The most important thing is that you use x and not t, because it's in terms of the variable x when we do graphs, and not in t. You see that it's in for variable t. And then yeah, just check that the function's correct. So when you enter here, most of you panic because you see a blank screen and you're like, oh my goodness, where is it gone? I've done something wrong. Well, you haven't done something wrong. You just need to change the window settings. Now, in the window settings, you know what it is. We've done it all before. But if you really want, you can click zoom fit and adjust it from there. But I don't like doing that. I prefer to understand the problem and put in the correct domain and range related to my problem. So this is the default setting, so I need to change these now. So if I look back at the question, I need to think carefully here what these mean. So the 5.6 is the amplitude. However, the amplitude is shifted 14.9 up. So imagine the amplitude being 5.6 and negative 5.6, and it's been shifted 14.9 up. So that tells me that the highest possible value it can be is really around 22. So I'm going to make my y max just 25, just going to round it off. And then my y min, well, if it's negative 5.6 and I add 14.9, it's going to be positive, isn't it? So I'm just going to keep that negative 5 so I can see the x-axis. I don't want it to be higher than that. So I'm going to make that my y. Then looking at the x, what's it in terms of? Well, it's in terms of time, and time is the number of hours after midnight. So if midnight is 0 and we have 24 hours in a day, that means that I'm just going to make that negative 5 just so I can see the left hand side, the axis, but really it should be 0. And then if there's 24 hours in a day, well, I'm just going to round it to the nearest 10 so that I can see the full graph. So think about what I did there. I didn't just zoom fit, I tried to understand the problem. I tried to think about the amplitude, the vertical shift, and also what t was in terms of, and it was in terms of hours, where midnight is going to be 0, 0. So putting that in, I'm able to now see my graph. Now it's also important that you have your graphing settings here in radians. So you want your graphing angle in radians. If you don't have that in radians, it's not going to come out nice for you. So you want your graphing angle in radians. So there we go. Now I can analyze my graph. So if I think about the question, well, what is the period of this function? Well, this one, you actually don't even need to look at your graph. We can, because you can see that it's a sine graph, and sine graph starts at 0 normally and goes up and goes down and back up. So here is roughly the middle point of the sine graph. Imagine that's the 0 line here. You can see that it goes up, down, and then back up. So that's one period. But we need to use the formula. Remember, period is equal to 2 pi over 360. So, 2 pi over b. So 2 pi is 360. So this is my b, the 0.524 is my b. So if I want the period, all I have to do is 2 pi divided by my b value. So 2 pi divided by 0.524, and you should get an answer of 12. So A, you don't really need to pop it in, you just use a simple formula. B, estimate the depth of the water at midnight. Well, the depth of the water at midnight, well, midnight is the y-intercept, because 0, 0, 0, 0 is midnight, and that's, we want hours after midnight, so that means that this here is midnight, the origin. So I want to find the y-intercept. So how do I find the y-intercept? Well, you could do it by calculator by just substituting 0 in for x and working out the answer, or you can just do graph trace. And then if I type in 0 and enter, it will tell me that when x is equal to 0, y is equal to 9.49. So that's saying that when it's midnight, the depth of the water is 9.49 meters. Then for C, it says estimate the depth of the water at 2 o'clock. Well, 2 o'clock is 1400 hours. So that means it's going to be 14 hours after midnight, because midnight is 0 and 1400 is 14 hours after midnight. So I just need to keep graph trace on and type in 14 and enter. And then I'll get the depth of the water at 1400 hours is 13.5. Last question, at what time will the water first reach its highest depth? So the highest depth, well, is this point, and this point. However, it says at what time will it reach its first. So here is the first time. So I just have to go to menu, analyze, and I know that it's a maximum. And then you click lower bound here. You drag it with your finger on the D-pad. Remember, this is the D-pad here that you drag it across, and then you click using this button. Just drag it across, and then when you get past the maximum, just click again. So there we go. So 5.5. So that's going to be 3:30 p.m. because it's 15. And then 0.5 in terms of time, because remember it's 0.5 hours, that means 30 minutes. So it's going to be 15, 30 in 24-hour time. So just be careful when you're converting it into time. So there we go. I've shown you how to put the trig function into the GDC. You've got to make sure it's in radians. It's very important you understand the problem, so you know your amplitude, your vertical shift for your range, and you know what the x domain is in terms of, if it's in terms of time, etc. Thank you very much, guys.